All right, so the domain of a function is basically the set of all input values that are allowed to be put into the function. So values that would be able to be calculated or computed, mathematically speaking. In real life, maybe think of like a washing machine and where you have to put quarters into the machine. If you try to put pennies or dimes, the machine won't work. It'll just spit them out. So the domain is usually going to be quarters or dollar bills. Um, that's one way to think about it in real life. So sometimes it's usually easier to figure out what values you can't put into the function. And in this case, it would be values that would make the denominator equal to 0 because we can't divide by 0. It would be undefined. So we solve 5x minus 3 for the 0. So we set 5x minus 3 equal to 0. And when we do that, add 3 divided by 5, we get x is equal to 3/5. But x, we will say it can't be 3/5 because that's the one value that we can't put into this function. So the domain will be all the values except 3/5. So in interval notation, it would go from -infinity to 3/5, open parentheses because we don't include 3/5. And we use a union symbol and we go back to 3/5. Kind of weird, but that's what you got to do. And we use parentheses around infinity because we can't include infinity because infinity is not really a number, it's a behavior. Now, just for a bonus fun, let's draw a number line because it's really good to just get used to always visualizing this in your head. So to the left, -infinity, and to the right, +infinity. And there's going to be an open circle at 3/5. So this would be called a jump discontinuity if you remember functions and whatnot. All right, so let's look at the next one. So here we have y equal to 3 to 2x power over x squared plus 5x minus 14. And so the top functions, or the 3 to 2x, is okay, works for all values of x because you can raise any value as an exponent, whether it's negative or positive. Now the x squared plus 5x minus 14, let's try to figure out what values, if there are any, that would make that 0. And it would probably be easiest to just factor this first. So what we're going to do is we're going to make x squared plus 5x minus 14, factoring it down. This will be x plus 7 times x minus 2. And again, this can't be equal to 0 because that would make the function undefined. So we solve this, so to speak. So then we have x plus 7 can't be 0. And then we have x minus 2 can't be 0. So then that means x can't be -7, and then x can't be -2. So these two values of x would not be in the domain. So the domain would be all real numbers except these two. So we skip these. So on a number line, again, -infinity, +infinity, we jump over -7. We start up again, up to -2, open circle, jump over -2, and we go again to the right towards +infinity. So using interval notation, -infinity, comma -7, union, -7, comma -2, union, -2, comma +infinity. And parentheses around all of those because we don't include any of those values. So that's our domain in interval notation. Let's go through one more here where we're going to look at a radical function. We're going to have y equal to the square root of 2x plus 7. And outside of that, we're going to add 5 over x. Now, let me separate that. Put some more space up there. Now, here, we can't let x be 0. So x can't be 0. That'll be one of the undefined values. Now, for this radical, or the square root function, remember, we can only take the square root of numbers that are positive or 0, so values that are greater than or equal to 0. So what we're going to do is we're going to set 2x plus 7 as being greater than or equal to 0. And then we solve for the set of values that satisfy this inequality. So take it away 7. 2x is greater than or equal to negative 7. Divide by 2. You get x is greater than or equal to negative 7 halves. So the domain would be the set of values greater than or equal to 7 halves or negative 7 halves, but not including 0. So let's do a number line again, because that usually helps. It's always good to have a visual when doing math. So let's start at negative 7 halves. This is negative 3.5. And we're going all the way to the right to infinity, except let's jump over 0, because we have to skip 0. So in interval notation, actually, no, we're going to put a bracket because we can include negative 7 halves, comma, 0, parentheses around the 0 because we're not including 0. We're going to jump over it. 0 again with parentheses, comma, infinity. And that's our domain in interval notation. So I hope that helps. Good luck.